Okay, let's take a look at the last question on the practice exam. So it says if f of x is equal to the square root of x, then what is f prime of a? So we haven't gotten to f prime in class yet, but f prime plays a big role in the course, as you're going to see so far. As you're going to see in the future. Um, what it means is this is just the slope of the tangent line through the point, or let's say at the point a comma f of a on the curve. Okay, so can you understand what I mean? Like, this is kind of what f looks like, and so what we're doing here is we're just taking some a on the x-axis, and we're looking at some point above, which is the point a comma f of a, and now f prime of a is just kind of shorthand for the slope of the tangent line through that point. Whoops, okay. So when we talk about this in class, I may call it the limit as h goes to 0 of f of a plus h minus f of a over h, and that is the definition using the limit as h goes to 0. There's another way. You can also just think of it as our old dy dx, and so maybe it's helpful just to compare the two. See if I can move this. Whoops. Where did it go? Okay. So what's the difference between dy dx and this thing? Really nothing. So dy dx is, what would that be? This is dy, what is that? That's f of, the point where we do stuff, you always have that thing plus dx, and then you have minus f of a over dx, right? And so this is just this difference that I'm always talking about between these two things that people are kind of obsessed with, but that really doesn't make much difference. So you can solve this problem either way you want, and since we're kind of more familiar with it, I'm just going to go ahead and which one should I do? I'll do it this way. Okay, I'm going to do it the way that the world at large says is the wisest way. So let me try to delete this, and God only knows what else I just lost, but this is the limit that we're going to do right here. And once I set it up, it's going to look really familiar. We've done things like this in class before. So let's look at the limit as h goes to 0, and now let's just unpack all this stuff. Here's the function f. So what is this going to be? This is going to be the square root of a plus h, and this is going to be minus the square root of a. Okay, and we've got h on the bottom. So what you want to do is, you should really be thinking about somehow canceling the h in the bottom. So let's forget about the backstory and let's just look at this limit for a second. So notice that we can't solve this limit by plugging in, because if you do, you get 0 in the denominator, which gives you, something that's not defined. So we have to somehow cancel the h. So let's just use the trick that we always use for these things, which is rationalizing the numerator. And I'm just going to rewrite everything down here. So we've got the square root of a plus h minus the square root of a over h. Okay, so rationalize the numerator, and that gives you the square root of a plus h plus square root of a all over the same thing. So that's why you can do it, because it's the same thing over itself. It's just like multiplying by 1. The square root of a. And now, so we've got this, what in class I've been calling the difference of squares thing. So the only difference between these two is the plus and minus sign. So that means that we get a plus h, so that's this part squared, right? Minus this part squared. And so what is that? That's a. And this is all over, we have h, this h, but h is also multiplied times all this nonsense, and so I have to write that there too. Square root of a plus h plus the square root of a. Okay, now notice that our trusty cancellation miracle has happened. Okay, the a's all disappear, and what am I left with? On top I've got h, and on the bottom I've got h times some stuff, a plus h plus the square root of a. Okay, so what that was supposed to be is my hand using the pen to cancel the h, and so that leaves 1 over the square root of a plus h plus the square root of a. Okay, so we've gone a long way. We started with this thing, okay, and we saw that it's really the same thing as this. And remember, what we want to do is take the limit as h goes to 0. Now we can do it just by plugging in. By the way, this is a, not 9. Okay, so we've got the limit as h goes to 0 of 1 over the square root of a plus h plus the square root of a, and plugging 0 in for h is great. Okay, no problem. So this just becomes the square root of a plus the square root of a, and if you want you can rewrite it as 1 over, you can probably rewrite it better than that, as 1 over 2 times the square root of a, and that's the answer. Okay, great, fantastic. So let's just review here. Alright, so this turned out to be 1 over 2 times the square root of a. And that's the best that we could do. Maybe some people are, I can hear somebody saying, what, we're done? Because a is not a number, and so it doesn't seem like that should be the final answer. Why is there a letter in the final answer, Hunter? But that's the best that we could have done, because they were asking for the slope of the tangent line at a point that they named with a letter, and so it depends on where you start, right? And so our answer had to depend on the letter too, and there it does. That's the best we can do, and that's the end of the question.